This is summary of thermodynamics marathon session video done by Vijayan Singh sir from Yourpedia. First, thermodynamics. Thermo means represents energy. It can be stored energy or it can be energy in transition. Stored internal energy, kinetic energy, potential energy, transition, heat to work. Dynamics means transformation. Heat to work. Energy can be conservative, non-conservative. Conservative is which can be stored, non-conservative which cannot be stored. Last form of energy like friction. Difference between thermodynamics and heat transfer. Thermodynamics is larger topic. Heat transfer is sub part of thermodynamics. Heat transfer only transfer of heat, no transformation, no transformation into work. Only transfer from one temperature to another temperature. Zeroth law about temperature thermometer design. First law about internal energy. Second law about entropy. Third law about absolute zero Kelvin. Why zeroth law is named as zero? Because it is stated after first three laws, but it is basic as it is related to temperature. It is basic than first three laws, so it is stated after three laws, but it is basic. So chronologically, it is named as zeroth law. Zeroth law, if A and B are in equilibrium with C separately, then A, B are also in equilibrium. If two bodies are in thermal equilibrium with third body separately, then those two bodies are also in thermal equilibrium. Basic principle used in thermometer. At atmospheric pressure, boiling of water, boiling liquid plus liquid to vapor, 100 degrees centigrade, freezing ice to water 0 degrees centigrade. System, region or space which we conduct study on. System plus surroundings is universe. E is equal to U plus KE plus PE. Insulated system, thermoflask not perfect. Thermoflask not perfect. Isolated system, universe, perfect or ideal. dq is completely equal to 0. Insulated means we'll create around it so that heat transfer is very less. In example, thermoflask, which is not perfect. Systems, heat transfer based on heat transfer and mass transfer. Closed system, there will be heat transfer but no mass transfer. Open system, there will be heat transfer and there will be mass transfer also. Insulated or isolated system, there will not be heat transfer nor mass transfer. Piston cylinder mechanism versus IC engine. Piston cylinder engine, here DQW, everything is closed, but IC engine, gases will enter and exhaust gases will leave, so it is open system. Draw Otto cycle. PV diagram 1 to 2 is isentropic compression, 2 to 3 is constant volume heat addition, 3 to 4 is isentropic expansion, 4 to 1 is constant volume heat rejection. How do you calculate expansion work? 3 to 4 is expansion integral PdV. W1 to 2 is equal to P3V3 minus W P24 is P3V3 minus P4V4 by gamma minus 1. Here V4 equal to V1, so we can replace V1. Why integral PdV is calculated, not integral VdP when it is open system? Because whenever there is expansion or compression work, inlet valve and exhaust valve are both closed, so entire system behaves as closed system. Here it is true that it is open system and gas will enter, but when there is expansion or when there is compression, it will be closed, those walls will be closed, so entire system acts as a closed system. What is pressure cooker? Here it is both open and closed because as pressure increases, unsteady state, closed system. At steady state, constant pressure, dead weight lifts and allows mass flow, so it is open system. Normal vessel heating, constant atmospheric pressure, open system. Thermodynamic property like T, P, temperature, pressure, volume, Ke, P is entropy, in terms of which we can define state of system and is measurable. Heat and work, not property. We can't measure at a particular state. Heat and work, form of energy. Property, intensive, extensive. Intensive, independent of mass. Example, specific any term. Extensive, dependent on mass. Heat and work are not even property to be intensive or extensive. Not even property, first of all. Control volume, approach, system approach. Open flow system is control volume, fixed space. What matter is not fixed. In closed system, fixed matter, but space is not fixed. Heat and work path function. dq is equal to delta u plus dw. This representation is for path function. Integral of dq is equal to integral cyclic integral dw. Work integral pdv, closed reversible non-flow work. Non-flow work. IC engine positive work, reciprocating compressor negative work. Minus integral vdp, open reversible steady flow. Work done by the system is treated as positive. What is difference between minus integral VDP and steady flow energy equation work? Here SFE Q plus H1 plus C1 square by 2 plus GZ1 is equal to H2 plus C2 square by 2 plus GZ2 plus W. If we neglect KE and PE, we get same. Like if we cancel KE PE terms, then Q is equal to H2 minus H1 plus W. dq is equal to dH plus dW if we write in differential form. First law, dq is equal to du plus pdv is equal to dH minus vdp. So from that also we will get dW is equal to minus integral vdp. We will get the same. Thermodynamic equilibrium, thermodynamic properties become constant. Measure and define, we can measure and define state. Thermal equilibrium, temperature, mechanical equilibrium, pressure, chemical equilibrium, composition constant, electrical equilibrium, voltage constant. Quasi static, quasi means almost, static means stationary. Reversible, irreversible, all processes in reality are irreversible. Internal energy U, molecular energy of thermodynamic matter, UKE, UPE. C max directly proportional to root T, UKE directly proportional to T. Ideal gases UPE is equal to 0 because molecules are apart by large distance. So potential energy is 0. U is equal to UKE is equal to F of T. So for ideal gas, delta U is equal to CV delta T is equal to CV into T2 minus T1. Enthalpy is thermodynamic property written as H is equal to U plus PV. Here PV is flow work, small h is equal to small u plus P small v. What is enthalpy, entropy, and internal energy of water in glass? Yeah, in interview they will have a glass, so they may ask this question. For a liquid, Cp is equal to Cv is equal to C. For water, C is equal to 4.18 kilojoule per kg Kelvin. H delta H is equal to H2 minus H1 is equal to Cp into T2 minus T1. Here reference is taken as 0 degrees centigrade where H1 is equal to 0. H is equal to 4.18 into 30 minus 0. Delta U is equal to C into T2 minus T1. U also it will come same. S2 minus S1 is equal to delta S is equal to C into ln of T2 by T1. S2 is equal to 4.18 ln of 303 by 273 as room temperature is around 30 degrees. Difference between work and heat and work. Heat is low grade energy, work is high grade energy. In an electric room, a person is there, electric heater ice karate is given. Your room, if room is considered as system, work is input by electrical heater in which changes internal energy delta E. If person is treated, then dq from heat is considered as heat from heater, as work is given to heater, dq is transferred to the person. Fridge, electric device like fan or fridge will increase internal energy by increasing temperature of room, as if that room is considered as system, w will be inlet, which increases delta u. Pressure and temperature absolute values. Pressure only for fluid because collision of molecules. Pascal and Newton per meter square. 1 bar is equal to 10 power 5 Pascal is equal to 100 kilopascal 1 atmosphere. uh, 0 Pascal can exist, but 0 Kelvin cannot exist. 0 Pascal molecules there but not collide. Temperature, measure of degree of hotness or coldness, Kelvin SI in degrees centigrade. Proof, efficiency is equal to 1 minus T2 by T1 when T2 is equal to 0 Kelvin, efficiency is equal to 1, not possible as per second law. PV is equal to MRT. Here P is absolute, T is absolute in Kelvin. If 10 power 5 bar is 1 at 10 power 5 Pascal, which is 1 atmosphere here taken as reference, then 0.6 bar is represented as 0.4 bar vacuum, which is down to that 1.4 bar is represented as 0.4 bar gauge, which is above 1 atmosphere. Ideal gas, perfect gas. Assumptions, intermolecular distance are very large. Volume of molecules negligible compared to volume of container. Ideal gas, PV is equal to MRT, PV is equal to NR by T, PV is equal to rho RT. R bar is equal to universal gas constant is equal to 8.31 for kilojoule per kg Kelvin, kilojoule per kilomole Kelvin. R is equal to R bar by M is equal to for air 8.314 by 29 is equal to 0.287 kilojoule per kg Kelvin. Real gas van der Waals equation P plus A by V square into V minus B is equal to R bar T. P plus A by V square, correction factor for molecular attraction. Molecular distance. Okay. Bernoulli equation from SFE. SFE is equal to Q plus H1 plus C1 square by 2 plus GZ1 is equal to H2 plus C2 square by 2 plus GZ2 plus W kilojoule per kg. Q is equal to H2 minus H1 plus C2 square minus C1 square by 2 plus G into Z2 minus Z1 plus W. Differential form dq is equal to dh plus cdc plus gdz plus dw. dq is equal to du plus pdv is equal to dh minus vdp. Put dh minus vdp here. Here we can be written as 1 by rho. Finally, after cancelling dw neglected, dp by rho plus cdc plus gdz is equal to 0, Euler's equation. P by rho g plus c square by 2g plus z is equal to constant, Bernoulli equation. Free expansion, example tire burst or balloon rupture. Gas expansion against vacuum, wall collapse suddenly, very fast so it is adiabatic. Q0 delta U plus W0, so delta U is equal to 0, U1 is equal to U2. Ideal gas U is function of temperature, T1 is equal to T2. Throttling H1 is equal to H2. Choking, narrow passage, capillary porous plug, closed valve. A1 C1 is equal to A2 C2. Stress of E Q0 H1 plus C1 square by 2 plus GZ1 C1 C2 same, Z2 W0 Z2 Z1 same, H1 is equal to H2. First law closed process dq is equal to delta E plus dw. Cyclic integral dq is equal to cyclic integral dw. Open or flow system cycle process. For process unsteady SFE q dot plus m dot E1 is equal to delta E dot plus m2 dot E2 plus W. SFE Q1 Q plus H1 plus C1 square by 2 plus GZ1 is equal to H2 plus C2 square by 2 plus GZ2 plus W. Second law quality Kelvin Planck discusses about quality of energy. Kelvin Planck statement: based on heat engine, efficiency cannot be more than 100. Clausius statement: based on refrigerator and heat pump, COP cannot be less than 1. Clausius inequality: cyclic integral dq by t less than or equal to 0 for cycle. For process, dq by t less than or equal to ds. dq by t plus sgen is equal to ds. Sgen is entropy generated. Irreversibility: I is equal to T naught into ds gen is equal to T naught into ds universe. PMM1 perpetual motion machine of first kind, everlasting. dq is equal to 0, but dw produced Violet's first law. dq 0 delta E plus dw. Perpetual motion of second kind, Violet's second law. T1 Q is supplied only with one temperature, fully is converted to W. Carnot, why Carnot is most efficient cycle? Now what for draw Otto cycle, PV, TS diagram for Carnot cycle. Here both are reversible, but temperature of heat addition maximum for Carnot cycle. Carnot also assumed external reversibility, not possible to be at same temperature, because here heat is supplied throughout at constant temperature, that is external reversibility. Otto cycle is reversible but only assumed internal reversibility. Reversible adiabatic, PV power gamma is equal to constant. Ideal gas equation, PV is equal to nRT. TV power gamma minus 1 is equal to constant. T power gamma by P power gamma minus 1 is equal to constant. PV diagram, PV power gamma is equal to C, T is equal to C. Isentropic versus reversible adiabatic. Second law, ds is equal to dq by t plus ds gen. ds gen is equal to 0 for reversible, ds gen greater than 0 irreversible. ds is equal to 0 isentropic, dq is equal to 0 adiabatic, ds gen is equal to 0 reversible. If it is reversible adiabatic, it is always isentropic, but every isentropic is not reversible adiabatic. Entropy, degree of disorderness or randomness, TDS is equal to CVDT plus PDV is equal to CPDT minus VDP. Okay, this is first law and second law combined together, both for open and closed system, reversible and irreversible, because everything here involved is a property, so these equations can be used for anything. Entropy change for ideal gas, S2 minus S1 is equal to Cv ln T2 by T1 plus R ln V2 by V1 is equal to Cp ln T2 by T1 minus R ln P2 by P1 is equal to Cp ln V2 by V1 plus Cv ln P2 by P1. Entropy change for reservoirs. C is infinity. Delta S is equal delta S1 is equal to minus Q by T1. Delta S2 is equal to minus plus Q by T2. SG is equal to delta S universe is equal to S system plus S surroundings is equal to minus Q by T1 plus Q by T2 plus Q by T2 is equal to Q into T1 minus T2 by T1 T2 greater than 0. Entropy change for solids and liquids delta S is equal to NC ln T2 by T1. Available energy and availability and exergy. Maximum work obtainable from given heat input. Efficiency Carnot is equal to 1 minus T min by T max. Efficiency of Carnot max is equal to 1 minus T naught by T max. T naught is surrounding temperature. W actual is equal to Q1 into eta actual. W max is equal to W reversible is equal to Q1 into eta C. A available energy is equal to W max is equal to Q1 into 1 minus T naught by T1. QR minimum unavailable energy. W max available energy. Available energy and unavailable energy in Otto cycle. First draw Otto cycle PV TS diagram. Then here T naught. One is T naught because it is suction. T naught the DS that is unavailable energy. Everything above is available energy. W net is only this area, but everything above is combined is called available energy. Reversibility is equal to I is equal to W max minus W actual is equal to T naught delta S universe.